All right, guys, let's look at this again. We're looking for finding the inverse using the identity matrix of a matrix that's larger than 2 by 2. So I chose a 3 by 3. And how we find that is we're using the identity and simplifying it to reduced row echelon form to find its inverse. So let's look down and see how that works. Sorry, a little tickle there. So starting off, on the left-hand side, we have the original matrix. And on the right-hand side, instead of having a total column that we have in other matrices, we use our identity matrix. And the identity, again, of a 3 by 3 is from the upper left-hand side down to the right-hand side of a diagonal of ones, with everything else as zeros. Now, what we're trying to do is we go through reducing this to reduced row echelon, which means that the left-hand side will become the identity matrix, will look like the identity matrix in the end. So as we go along, I show you exactly what I've done. I have row 2 minus 2 times row 1 and replace row 2. So you can do row 2, and I typically do those off to the side rather than just in your mind, because we can make easy mistakes mathematically. But I typically would go to multiplying it by a -2 on the row 1 and then adding the 2 together. It's going to replace row 2, and this is where this new row 2 comes from. Now it's easy to, when you put this here, this helps you remember what you're doing. Because again, we're human, we make mistakes, and would hate for you to put it in the wrong row and then you get off track. Next thing we do is I did row 3, and then I multiplied row 1 times 3, added those together, and replaced row 3. This is where you can see that row 3, what it looks like here, has now been replaced going here. Now I'm choosing, my go-to is always to stay with the columns. So I have now 1, 0, 0. I now have the 1 in the middle. And then my goal, it doesn't matter which order you do it in, but I typically will either go by columns or I'll do my whole diagonal as ones first, always trying to keep the underneath the zeros as we go along. Now this one is just multiplying by 1/3 of row 3. When you do that, it means you're not replacing it anyplace else, but you're just taking 1/3 of that row, and you can see I did right here. Let me scroll down just a little bit more. Sorry, the page got a little cut off, but we have continuing on until we get the diagonal as ones and the zeros either above, not either, but above and below that diagonal. And when that occurs, the left-hand side is now the identity. The right-hand side is its inverse. So we have in the end, our inverse of our matrix A is that right-hand side. If for any reason the left-hand side cannot reduce all the way down to reduced row echelon, then there is no inverse on a 3 by 3 for that particular one. So it has to be able to go all the way down to have an inverse.